Hello, assalamu alaikum everyone. Welcome to my channel Math Madness by Aisha Khalid. So, in the previous videos, we had discussed integration basics and we also discussed how we can do integration by recognition. So, I'll just quickly go over the concept again and then we start with the past paper questions where I will explain you how we do integration by recognition in partial fractions. So we know when there's a function in the denominator and it's differential, it's there in the numerator, it closes into ln f of x plus c. So just quick examples. 2 upon x. Let's take this 2 outside, so it becomes a 1 upon x. The constants can be taken inside and can be taken outside because they're over here as multiples. So it doesn't really make any difference. The function is x and the differential of x is 1. So it sets in this entire formula thing. So it becomes 2 ln x. Let's take another example. For example, if you have a 3 upon 1 minus x. Now, 1 minus x has a differential of a minus 1. And we don't have a minus 1 outside in the numerator. We just have a 1. So what we do, we introduce a minus sign. And when we introduce, we also take a counter effect. So minus minus is a plus because you cannot just introduce anything like that in math. You need to have a cancelling effect generated. So this closes into, this is the function, this is its differential. So minus 3 ln 1 minus x plus c. Now the third thing, 4 upon 1 plus 2x. Differential of 1 plus 2x is 2. And 4 can be split into 2 into 2. So this 2 goes outside and inside we are left with a single 2. Now this fulfills the criteria of this formula. So it becomes 2 ln 1 plus 2x plus c. Always write a plus c when there are no limits. Let's do another example. 3 upon 5x minus 1. Now the differential of 5x minus 1 is a 5. We don't have a 5 outside in the numerator. We have a 3. Let's take that 3 outside. Now introduce 5. We write a 5 in the numerator. We also write a 5 in the denominator. So this closes into ln plus c. Now let's start with the partial fraction questions and see how this concept is applied. Express f of x in partial fractions. 2x squared plus x plus 8 divided by 2x minus 1 x squared plus 2. This will break into a upon 2x minus 1. Since this is a quadratic factor, so it will become bx plus c divided by x squared plus 2. Now let's take the LCM. Now, using the cover method, which means supposing values of x, we find the values of a, b, and c. So in this particular integration topic, actually I'm also revising partial fractions. So look at the working very carefully. The first value of x that can assume is an x equals to 1 upon 2. So that this bracket cancels out. Now because we have a square here and any value of x becomes square, so it will not cancel out. So the next best value to suppose is always x equals to 0. And after 0, since there are 3 unknowns, the next value that I will suppose is going to be 1. You can also suppose minus 1, 5, 3, your choice. Let's input a half. So 2 into half square plus half plus 8 equals to a half square plus 2. And this thing entirely cancels out because this becomes a 0. So this cancels out. Now, this becomes, let's do the calculation. 2 divided by 4 plus 0.5 plus 8, it's a 9. 0.25 plus 2 equals to a, 9a upon 4. This cancels out, so value of a becomes 4. Now, when x equals to 0, 0, 0, we get an 8. 2a. Now, you need to be good with mental calculations. Plus, this becomes a 0. So, c, 0 into a minus 1. This becomes, we have the value of A as 4. C equals to 8 minus 8, so the value of C is a 0. Now let's input 1. 2 plus 1 plus 8 equals to 1 plus 2 is a 3A plus B plus C. 2 minus 1 is a 1. Now 8, 9, 10, 11 equals to 3A plus B plus C. C is a 0, A is a 4. So 3 into 4 is a 12. So value of B becomes minus 1. Let's input everything in the fraction again. Plus minus x upon x square plus 2. Now, the next part says, this is the first part's answer. Now, the next part says, you have to integrate it with respect to 5 and 1. So, we have to integrate the function. So, in place of the function is this. So, in place of this function, I will write its partial fraction. And we have to write the answer in terms of ln c, where c is an integer. So, looking at the answer's requirement is very important. Let's integrate it with 5 and 1. Now this is all integration by recognition, meaning 2x minus 1 differential is 2. Split it. This 2 goes outside, 2 remains inside. Plus, the differential of this is at 2x. And we have a minus x in the numerator. Can I take a minus outside? So it becomes x upon x square plus 2. Introduce a 2 because we need a 2 in the numerator. We need a 2x in the numerator. Now this becomes 2 ln 2x minus 1 minus 1 upon 2 ln x square plus 2. Now we have the limits 5 and 1. We put the bracket and we write the limits of 5 and 1. 2 ln 2 into 5 is a 10, minus 1 is a 9. ln 5 square is a 25, 25 plus 2 is a 27. Minus 1, 2 ln 1 minus half. ln 1 plus 2 is a 3. Now now remember ln 1 is equals to 0. Wherever you get ln 1, you directly make it 0. So this is a 0. 2 ln 9 minus half ln 27. Minus minus is a plus half ln 3. Take ln common out. 9 square is an 81. Minus means it goes division. Square root 27. Plus means multiplication because we're taking the log common out. Please revise the log video or watch it in order to understand the basics of logs if you're lacking in log basics. This is square root 3. Now, 3 times 1, 3 times 9. And square root 9 is a 3. 3 times 1, 3 times 27. So, ln 27 is my final answer. And they said that this is going to be an integer and I'm also getting an integer answer. Let's do another question to have more grip on this topic. So the first question says express this in the partial fraction. Since both are linear factors in the denominator, it will just open up with constants in the numerator. Take the LCM. Now the first value of x is going to be a minus half. And the other value of x is going to be a half. Let's input half minus half. So it becomes minus half means this thing cancels out. B 2 into minus half minus 1. Then input a half. Minus 2b equals to a 2. So b becomes minus 1. Now 1 plus 1 is a 2a equals to 2. So a becomes a 1. Now 1 upon 2x minus 1 minus 1 upon 2x plus 1. Now next part says using your answer to part A, show that f of x whole square. So I'm doing this part on this side so we have a better understanding of what the question is asking us. F of x whole square means this thing whole square. So in place of this function, I will write its partial fraction, which is 1 upon 2x minus 1 minus 1 upon 2x plus 1 the whole square. So can I say this is a minus b the whole square? So you open it up like a square minus 2ab plus b square. Now this becomes 1 upon 2x minus 1 whole square minus 2 upon plus 1 upon 2x plus 1 whole square. Now let's look at the middle term. The middle term is again the same function over here. So in place of this function, we will again replace it with its partial fraction, which is minus, then we write this entire fraction once again. Now 1 upon 2x minus 1 whole square minus 1 upon 2x minus 1 plus 1 upon 2x plus 1 plus 1 upon 2x plus 1 the whole square. And this is exactly what they want us to show. So we have shown the answer, proven it. Now the next part says you have to integrate with respect to 2 and 1 the same whole square function and get this answer. 2 upon 5 plus half ln 5 upon 9. And we have to integrate f of x whole square. So I'm writing this entire function here. Minus 1 upon 2x minus 1 plus 1 upon 2x plus 1 plus 1 upon 2x plus 1 the whole square. And we have to use the limits 2 and 1. Now this goes in the numerator, becomes a minus 2 plus 1 divided by new power into the differential of the inside expression. For this one, the differential is a 2. So what we do, we introduce a 2 here and we also introduce a 2 here. Minus 1 upon 2 ln 2x minus 1. Over here again, the differential required is a 2. So we introduce a 2 plus half ln 2x plus 1 plus 2x plus 1 to the power. This goes up, becomes a minus 2. Now, minus 1 upon 2. This goes in the numerator, becomes a 2x minus 1 minus half ln 2x minus 1 plus half ln 2x plus 1 minus 1 upon 2x plus 1. Now the limits are 2 and 1. After integration, we do not write integration. We write brackets and then we put the limits. Now let's input the 2 limit. Minus 1 upon 2. 2 into 2 is 4 minus 1, 3. Minus half ln 2 into 2, 4 minus 1, 3. Half ln 2 into 2, 4 plus 1, 5. 1 upon 2, 2 into 2, 4 plus 1 is again a 5. Minus 1 upon 2, 2 into 0, 1 into 2, minus 1 is a 1, minus half ln 1 plus half ln 2 into 1, 2 plus 1, 3, minus 1 upon 2, 2 and 3. Now let's do the calculation. Minus 1 upon 6, minus 1 upon 2 ln 3, plus half ln 5, minus 1 upon 10, minus is a plus 1 upon 2. This becomes a 0, we don't need anything. Minus half ln 3, minus is a plus 1 upon 6. Now, this cancels out. We are left with minus 1 upon 10 plus 0.5 gives us a 2 upon 5. So we are also done with this calculation. Let's take ln common out. Let's take a half and n because everything has a half. Now 5, there's a plus, so it goes in the numerator. Minus means goes in the denominator. And again, we have a minus. It means it also goes in the denominator. So this becomes 2 upon 5 plus half ln 5 upon 9. And this is exactly what they want us to show. So my answer is proven. Let's do one more question before I end this video. Alright, so the first part says we have to do express partial fraction, and this is a repeated factor. How do we open a repeated factor? 2x plus 1 plus b upon 2x plus 3 plus c upon 2x plus 3 the whole square. Be very, very careful with its LCM. So A requires this entire thing because it doesn't have it. B requires this and single this. And C requires just this expression because it has a double 2x plus 3. Equals to 10x plus 9. Now let's three values of x minus half. X equals to a minus 3 upon 2. And then x equals to a 0. Okay. Now when we input a minus 1 upon 2, this cancels out. This also cancels out. We are left with, let's input it. 2 into minus 0.5 plus 3 gives us a 2 square, which is 4a. Equals to, this becomes 10 into minus 0.5 plus 9 gives you a 4. So a is 1. I've done it directly. Done the calculations in the calculator and mentally. Now when you input a minus 3 upon 2, this cancels out. This also cancels out. 2 into minus 1.5 plus 1 minus 2c equals to 10 into minus 1.5 plus 9 gives you a minus 6. So the value of c becomes a 3. Let's input a 0. 0 means it's 9a plus 3b plus c equals to 9. Let's input the values of a and c. 9 cancels out. 3b is equals to a minus 3. So b value becomes a minus 1. Now next is 1 upon 2x plus 1 minus 1 upon 2x plus 3 plus 3 upon 2x plus 3 the whole square. So this is my answer to the first part where it says express it in partial fraction. The next part, you have to integrate it 1, 0 and prove the answer 1 upon 2 ln 9 upon 5 plus 1 upon 5. And the limits are 1 and 0. Let's integrate it. Now, for this one, we needed 2 in the numerator, so we introduce a 2 in the denominator. 2 in the numerator, why? Because 2x plus 1 requires a differential of 2. So we introduce it, we don't have a 2 in the numerator. This closes into ln minus, again 1 upon 2 ln, because this closes into ln and this is extra, stays outside. 3 2x plus 3 to the power minus 2 power plus 1 divided by new power into the differential of the inside expression. Now, what are the limits? The limits are 1 and 0. Let's input the limits now. When you input a 1, 3, 5. 2 into 1 is a 2, so 2 into 5. Now let's input the limits of 0, half ln 1 minus half ln 3 minus 3 upon 2 into 3. So lots of calculations are done mentally because they're easier to do. Okay, now here, half ln 3 minus half ln 5 minus 3 upon 10. This becomes a 0, minus minus is a plus, half ln 3 minus minus is a plus half. Minus 3 upon 10 plus 0.5 gives me 1 upon 5. Let's take half and ln common out, so it becomes 3 in the numerator because there's a plus. Minus goes in division. 5 multiplication and 3 in the numerator. So it becomes 1 upon 5 plus half ln 9 upon 5. And this is exactly the answer that they've asked us to show. Stay tuned for my next video where I will explain the other techniques of integration that are used in A2. Take care. Allah Hafiz.